Good day. This is John from Dan Best Racing Carburetor. I've been working a lot lately in the videos on idle and transfer slot, the transitional fuel delivery. Today I'm going to try and concentrate more on just the transfer slot and how much it's changed and what we have to concern ourselves with in order to get close to delivering something for the idle and the transfer slot to work for each individual application. So I have my little diagram here I used the last time. Right now this is going to represent the transfer slot. This is the idle. This happens to be the curb idle screw. This little distance here in this we'll call stick figure to represent the curb idle screw in the side of the metering block. I have an earlier style metering block to try and show the channels that are used. And I got a little light here and show the vertical channel for the idle transfer slot. They're both fed from the same vertical channel. Then there's a horizontal channel. I wanted to put this both as one on one side and the other, so it could be seen easier. Let's see if I can get that over there as the camera. So the fuel comes from the bottom of the main well in the traditional style. Just rotate this around. So when the carburetor is fully assembled, there's jets in the main well, main jets. This happens to be where my additional access point that I've mentioned in other videos. For assume right now we're going to do it the traditional idle transfer slot where the fuel will come in at the bottom of the main well. In this hole right here, you just bring it over here, right there. I like to drill, and I'm CNCing them, all the emulsion holes, and then drill the idle transfer slot jet at the same time, because then I can thread them at the same time with the CNC. That's the hole there. Let me see if I can. Oops. And I'm trying my best to continue to show, because a lot of times I find that people haven't spent any time to really understand these. They just go by, always I'm frustrated. I know it comes across my voice. 50 to 70-year-old information, it just doesn't apply anymore. So the idle transfer jet that's at the bottom of the main well, like I say, in Holly, sometimes they'll put it at the top of the connecting channel, right here. They'll put it at the top. Right there. Like I say, I put it here at the bottom. Once again, I'll squeeze it through. It goes right behind the jet in the main well. So when the fuel is in the float bowl and the jet is in there, the gravity will siphon the fuel so it's at the same level in the well when the engine is either off or idling, because the jet size is bigger than the idle jet. The main jet is bigger than the idle jet, so it'll still try to level off in the main well while the engine is idling. Then the fuel comes here, goes up the main channel, the idle well channel. Let's see if I can get that little thing to show in here again. Right there's the red, and it's up there. Then the cross channels here, as I showed before, from the channel there. Right in there. And from that point, it goes up, the air bleed would be here from the main body, and that is using for an anti-siphon device originally. Now we use it to balance. So this represents the main body at this moment. I'll show that in a second. Goes through this hole. That's the air bleed. This is the channel for the transfer slot. which is fed first. Then it's connected after it fills this channel, transfer slot channel. Then it's connected to the curb idle, which goes out to the idle. For this conversation for today, I want to look at the transfer slot and this channel. So when the fuel comes in here, it goes out through the main body here. All right. And this is a 4150, and it'll come down through this hole here. Right, and there's the little red again. And then down through the base plate. Now the important thing is over time, the 4150 metering block, and let me turn around so it's in a more conventional appearing way. The transfer slot is right there. Well, these systems haven't really changed in their location, so we're going from a fairly small butterfly, there's the transfer slot right there, to something with a much bigger diameter butterfly. The transfer slot system really has not changed, but now, as I said in the last video, the amount of air and fuel, the air going by the transfer slot, is distributed through the entire butterfly. And there's so many of these little things that are very hard to tell people that have been worked on. One of the things that we've had to work on, and some of the stuff sounds very silly, but we'll call it the slice, the angle, and the fit, both because the butterfly is not a true circle. It's elliptical. And the taper that is closed, so when we put the butterfly in, and we took a while before, you can see it goes in a little snug because it has to fit snugly in a hole, because if we make the elliptical in a different place, it'll be a shorter diameter distance at the throttle shaft than it would be across the perpendicular to the transfer slot, which means then the air would be going by near the throttle shafts here and here. So you're going to have you actually be able to see the space, the space on each side of the butterfly, allowing air to go through. So we've had to change the slice angle so that we can get it to the point where it can close. This is why I wanted to go over the transfer slot altogether today. So it can close, and we shortened up the transfer slot a little bit so it can be closed and not access the transfer slot. A lot of times in the 4500s, we suggest that you balance out the idle position with the primaries and secondaries, and then you can balance out the transfer slot position. We have shortened this. I'm going to try to remember now, about 50 thousandths we've shortened the transfer slot, so it's not always, when the butterfly is open, directly into the transfer slot. It's just idling on the idle. But the bigger the butterfly is as you tip it in, which is people don't think about, is on the opposite side from the idle transfer slot. You're accessing air. So the bigger the diameter is, what ends up happening, this is why it's, we're trying to send out so many tuning videos on the idle transfer slot, because it is a truly misunderstood area. The bigger the engines are, they're getting to be dyno engines, the camshaft has a huge interaction on the air coming down or not coming down the carburetor. The more overlap, the more air that comes up the exhaust. So the air coming up the exhaust is not drawing fuel through the carburetor, so the carburetor has to distribute fuel to air it doesn't see. Not only that, as your butterfly diameter increases and the tip end gets greater, so even though this is fairly close here, there's a huge access of air coming in the other side of the butterfly. You multiply that times the two primaries or the two secondaries, so you have a very little signal on the transfer slot for it to draw fuel. We can make the jet bigger, and we can try to do the things to make the signal a little bit better at the transfer slot. But this is always a challenge, going from the smaller and smaller butterflies to the bigger and bigger butterflies. As we go up in diameter, in order to make more peak power, lower the resistance, because we have the airfoil booster. This one happens to have the airfoil booster already in it. So these cars are great performers, but we're trying to work on the balance between the idle and the transfer slot. So we need to, educate the customer to tuning the transfer slot and the butterfly idle a little bit better. I think many people actually think about the air coming up during overlap at idle. I don't think people think about it. That's just what I believe. They don't look at the cam card, say, well, that closes late. When I'm going to do something and I need a throttle response, the next cam I got to design where the exhaust valve is closing a little closer to TDC. There's a balance between performance and getting the cam made correctly, so it's a little less what they call seat timing, bringing the exhaust closing seat timing in. But being able to tune through this is why I want to go through today. So the other thing I wanted to show in the transfer slot is, we've been working on making the transfer slot a little wider. Most of the jets for the transfer slots today, we start off with an 052, so you can obviously see this is greater than 052, so it's not a restriction to the fuel delivery. But the important thing is that in the transfer slot, the butterfly is going by so fast. I'm going to try and show this here. Turn it this way. When people are working the throttle, let's see here, put that back in. They don't realize when they're driving it that they're gaining distance so quickly that you begin to lose signal over that tiny little space. There's, the air distributes over the bigger butterfly, and so you're losing the isolation at the transfer slot, and then you lose signal. So the further away it gets, the less signal it's there. So what we've done in the splits, which we have done some 4 barrels this way, but everything takes time. We've widened. We've also moved the transfer slot from the base plate. This is the idle here, so because it's much bigger, the center to center, so we had to move the channels out in the splits. So the idle is in the base plate right there. But we moved the transfer slot into the bottom of the main housing. And the reason being that I moved the transfer slot into the bottom of the main housing here is it gives me the ability to widen the slot. And the wider the slot is at the butterfly, the more signal it ends up happening when the butterfly is transitioning over it. Let's see if this butterfly will work here, if I can use it as an example. You know, giving these videos, I tell you, it really takes a lot to try to get these videos to the customer. I like doing them, but it takes a huge amount to get them done. Now, this butterfly is not the right one for this, but I'm just trying to show here as an example the area where the butterfly passes. Now it's a horizontal slot rather than a vertical slot. So as it passes, once it gets this area, it draws, because there's more air going across, directly across that opening, so the pressure differential is greater. Then once the butterfly slightly passed, the low pressure area under the butterfly continues to draw fuel from the slot. So the horizontal slot offers a greater signal than the vertical. And we watch it on the wet bench. You can see the fuel drawing across that entire slot. Now the peak flow is still adjusted by the jet. In this case, they would be in the main housing right here, at the end of my finger. This is the transfer slot adjustment right here. This would be the idle adjustment, as I said in the other videos. What we're trying to do is let people know that the idle and the transfer slot can be tuned and adjusted. Transfer slot also can be had, and that was why we separated over time, and I wanted to explain that. We separated over time from just having a jet in the metering block to putting individual jets in the main housing for the transfer slot and the idle. And that came more because as we went up in butterfly diameters, in the 4500s and also the ultimate 4150s, we needed to split this, not because of the idle at that point, is because the transfer slot wasn't delivering enough fuel for the transients. We had several things going on at that point. We had the increased butterfly diameter, giving more open space for free air, this phenomena. So we tip it in, once again, it's the backside. As you tip in the butterfly, you're accessing more at the transfer slot, but you're also accessing more air that is not drawing fuel. So you're diluting or reducing the air passing the transfer slot here. So we needed more fuel to come in through the transfer slot. In order to do that and not have too much fuel coming in through the idle, the decision was to split the idle and transfer slot and have individual jets in the main housing. So they could be individually, because then we could take the idle jet and make it something like an 035. We could take the transfer slot, and we started off initially with an 052. And it isn't uncommon to have unobstructed fuel going to the transfer slot in some carbs where the camshafts are big butterfly, even some of the 1 3/4 butterfly 4500s. Depending on the amount of air that they have with the butterfly going past the transfer slot. As I say, I'm trying to show all these things. The transfer slot you guys all. The hard part is doing these videos and getting them to a point where people actually watch them. There's so much good information in videos. There's a transfer slot. And get people to watch it, it's equally hard. Because they already got the answer. On the 50, 75-year-old technology. So we went from, in the early ones, this is before we had the float bowl area. We needed to have more fuel coming through the transfer slots, so we moved the jet from the bottom metering block. We split them and we put them in the main housing. So the object of that first choice was to get more fuel at the transfer slot. It wasn't because we needed more fuel idling. At idling, we were able to get enough fuel at that point, this is a bunch of years ago now, to feed the idle. But, I don't want to call it progress, but as people dyno the engines more on the dyno, they just respond to having more free air. The carburetors got bigger, the butterflies got bigger. So at some point, and the overlap got bigger, then we really had to go back and take another look at the idle, because now they basically lost all vacuum at idle, so that had to get bigger. We had to find new ways to get it to draw fuel through the idle, so we put the tube in it. So it wasn't the vacuum created by the engine that was drawing fuel through idle, it was the pipette from the air going by the tube that created enough draw to get fuel there. And then the transfer slot wasn't delivering enough fuel, so that got bigger. And then ultimately, in order to try to increase the signal at the butterfly for the transfer slot, we had to go to a horizontal fuel delivery like we do in the splits. There is some 4500s as time goes on. All of the carbs will be adapting that. Then at some point, people were still struggling with getting them to idle because the vacuum was so low. And I'd like to say that all this stuff was intuitive, but it wasn't. Sometimes by the nature of somebody still, I would have so much idling fuel measured on the wet bench that I could have easily, through a gasoline carburetor, fed a methanol engine. Maybe twice what it would take to feed a methanol engine. The idle vacuum was so low. Then through process of discovery, and this is the important thing, as we've been improving the main booster, and this diagram is over here, the airfoil booster, for performance. This is the airfoil booster. I'm just going to show it now for the sake of the discussion. Right there. As we've been improving the boosters and all the things internal. That one I just showed you, I think, is the high flow booster for methanol, because of the diameter in it. As the boosters improved, as you're sharing the channel between the idle transfer slot in the main well, because now that's still coming off of here, once we began to draw booster signal, continue to improve the booster signal, then it would stall the idle and transfer slot fuel, which means the booster signal was the same or greater than signal is created by the engine at idle or slightly above idle, and our booster signal because of the repositioned Venturi was so strong that it would actually begin to draw a booster and stall the fuel in the idle transfer slot channel, which means it's certainly not going down, it's not going up, and people would recognize the engine wouldn't idle, or it would have a little hesitation going from idle past the transfer slot up, and that's because the fuel was stalling in the main well because the booster signal had gotten so high. In order to not have them drawing from the same position, we ultimately went to the new fuel delivery for the idle transfer slot, so it would be separate from the main well and the booster. And I know I always say the same thing. if somebody's gonna have the carburetor and they have the traditional idle, which we send out sometimes, or an earlier inventory carb that have the traditional idle fuel, just to separate these things takes nothing more than putting and this is the earlier one, plugging this 632, take the jet out, and you put a blank in there. At that point, removing the blankets here in the bottom, the float bowl area, so the idle fuel will be drawn from there and going into the transfer slot, so that no longer will the idle fuel be in conflict or the tug of war going on in the main well. So we're trying to get the carburetors to be more sensitive in that area constantly to make up for the fact that there is almost no idle vacuum. I just really wish that, with these $80,000 to $100,000 dynos, and people would just get a vacuum gauge. It would be such an educational moment. You go up to each engine, you put a vacuum gauge on it while it's idling. Then you instantly know if there's very low, and a lot of these engines will actually idle with less than 3 inches of water. Vacuum less than. Then as they go up, the inertia in the header will cause the air to be going out the header. They'll actually jump from less than 3 to maybe 3 to 5 at 3,500, because now at least some of the air will be going out the exhaust rather than up the exhaust. But the idle circumstance doesn't change, and they would instantly know to go from the traditional idle fuel delivery to this channel to the float bowl area to this channel. Problem solved, because now you're not splitting the difference between the booster signal in the main well and the idle transfer slot in the main well. You're no longer splitting that difference. One is fed from the float bowl, and the booster gets the signal from the main well and the jet. Basically problem solved. And as we increase the signal at the transfer slot with the new adjustments there, that will continue to improve, because we are trying to build carbs that will help with these problems as we've been regularly. I wanted to show some of these differences, so I've got my little camera here. Set this over here. I don't know if I showed in the same picture last time the differences between the new curb idle screw and the previous idle screw. Let me just move the camera down there a little bit, right there. But that's the differences. Now I'm gonna move the camera up to my computer, because I have my little tiny camera here to show some of these other differences. Let me just get it positioned better. There we go. There we go. All right. Now, the reason why I want to do that, let's see here, right there, is I want to show down the inside of the curb idle screw, which I haven't done. Now, that's the conventional curb idle screw. Down in the bottom that you see there, that's the hole that would be considered like a jet. It's a needle and seat. The tip of the needle through the threads screws down the hole, and you can literally close off the hole using the needle. And let me get, I know this, a lot of this is really not easy to do. Most people may be sitting home or ever work watching this, laughing their butt off. But this is not easy. They give you ways to see, because a lot of times people, and so the hole, that's the idle fuel delivery from the channel. This goes off to the main housing. Let's see if I can show before the hole there. Let's see here. So I can show the connection. Can I do that? Yes, there it is. That is the connection from the channel where the transfer slot comes down. Now, if that hole was not there and the other piece was not here, like in some of the secondary carburetors, it would just go off to the transfer slot in the main housing. The access to the idle simply comes from the curb idle screw. If no hole there, no screw to go in and out, no curb idle adjustment. So you're connecting the two channels via that tiny little hole. Well, as the engines went up in size, 1200 horsepower, through a single carburetor, in methanol and E85, the next thing we needed to do was to jump the needle size up, and then we had to make everything inside bigger in order to feed these engines and reduce the resistance it took to get idle fuel. So when somebody just walks up and arbitrarily turns these screws out, the difference between the intersection point there and the size of the hole in the football, you can see in there the hole is a ton bigger. All right, let me just, now I want to show you where I'm putting it. I'm putting it in the bottom of the transfer slot channel. Let's see here. And let me set that down. Let me hold this here. All right. There it is. Now that is at the bottom of the transfer slot channel. That's where the fuel for the idle comes from. So the transfer slot is fed first. Now the other thing that I neglected to say during this process, I'm going to go back over to my diagram here, that the transfer slot is an air bleed to the idle. So when there is no draw on the transfer slot here, any draw from the idle at this point, the air can go straight from the transfer slot down through that hole and right back out through the idle. So this also reduces the signal to the idle. The transfer slot reduces signal to idle because it's connected via the screw hole from one spot to the other. So when we take the metering block, I'm going to see if I can get that thing here. There we go. This is the newer metering block. I'm just going to go up here for a second. So this is the idle transfer slot channel here. So, I'm sorry, I'm moving it around so much. So the fuel comes here first. But when you get idle drawing from this hole here down through the cross hole, if there's no signal, no draw from the transfer slot, that becomes an air bleed, just like the air bleed at the top of the main housing. At the top of this channel goes off to the main housing. So now you have an air bleed. The transfer slot is an air bleed to the idle, reducing its signal once again. So the balancing out of all this lost signal because the butterflies have gotten bigger over the years, has caused all of these systems to, and it just needs attention. It can't be assumed. I've got thousands of wet sheets, but I can't predict the camshaft or the low lift exhaust side of the engine. The intake isn't as big a problem, but the low lift exhaust side flow, where the air is coming back up the channel, simply cannot be predicted. Or the restriction in the negative side on the headers, and how much free air is coming back down to this, can't be predicted. It just needs a little assistance from the tuner. Once I learn what system works for each one, I can put it in the build sheet working with the tuner. And a lot of times it has nothing more than to do, and this is the newer metering block here. Let me go back to the other picture. Let me change this. Simply, this is our newest metering block. At the bottom of the main well is the thread. Once again, I do it at the same time as I put the holes in it because it's easy to machine and thread. This would get plugged. Then the hole that goes through the metering block down here through this connecting channel goes over to the jet that's in the float bowl area. That would get opened. So depending on where I want to have the fuel restriction, I can either put it in the metering block or I can put it in the main housing. Same as when the carburetor is delivered to you. Depending on the idle vacuum, we can move the restriction from the metering block to the main housing so we can separate the adjustment, so that, especially when you get to the bigger diameter carburetors, so each one, and in different fuels. I believe the carburetor I'm holding here now is a methanol, high flow methanol carb, because of the diameter of the booster. You gotta have room behind the insert to move enough fuel to make anywhere from 1,300 horsepower to, if it's a blow through, 2,000 horsepower. So the booster has to change. But the adjustment gets split here so that the idle jet can be here one size and a completely different size. When it's in the bottom of the metering block, when either side of the metering block, and that's the fuel feeding the main housing, both idle and transfer slot, means one jet has to feed both. And sometimes the tuning of the engine requires they're tuned separately. So the one point that I wanted to add that I keep missing, I wish I could remember everything as I'm doing this, is that the transfer slot is an air bleed to the idle. So not only do you have the idle air bleed, which goes to the transfer slot as well, bleeding off signal to the transfer slot, but it also bleeds off signal to the idle. At that point, when the butterfly is low, the transfer slot is also an air bleed to the idle. In order to, we have so many things in conflict, taking signal away from the transfer slot and the idle, and having low signal to begin with because of the camshaft, that this does need to be learned, and it's just incredibly simple. Put a vacuum gauge. It's like putting a little mini dyno on the engine while it's idling. There's so many things that can be, detected by simply putting a little vacuum gauge. Putting a port. And I was thinking, where's the best place to put a port, especially in a new build? It's in the spacer. We built some pretty neat spacers. Let me just grab one quickly without knocking the building down here. Our Pro Style shear spacer for single 4 barrels look like this, where the shearing is here, then they're undercut. Simplest way to add a little vacuum gauge, I mean, it's incredibly simple. The 1/8 inch tube, I think it drills out to something like 3/16 on the outside. Right here, right there, right on the side of the channel. You put a vacuum gauge on that. Just the idling, or even call, and I will give suggestions on what is to set up the change in the metering block or in the main housing to optimize the intake manifold vacuum. The other lesson I had just recently, as I mentioned before, the same thing. We had a twin screw supercharger that because the nature wasn't depending on the camshaft to create vacuum under the carburetor. The twin screw produced the vacuum under the carburetor. That's what the carburetor sees. That we had to go completely the other direction and make everything smaller, air bleeds bigger, because it had so much more signal underneath the carburetor created by the twin screw. Simply a vacuum gauge would solve all of it. Little 1/8 inch. Let me just get the little thing. I know my videos really are odd, but they're better than nothing. Maybe not much, but I'm really trying hard to get the information to the customer. That's my goal. Customer satisfaction. This tiny little tube. Somebody needs any, just ask. We'll send it with the carb. You drill out the spacer. You put it right in the side here. You put a simple vacuum gauge on it. Done. You'll know exactly what to change in the metering block, in the main housing, based on how much vacuum your engine creates in an idle. Because that's what the transfer slot and the idle delivery will see. When the butterflies are closed, it sees directly. If you idle it up and you can see where you are and see if the vacuum goes up, that'll help you change the transfer slot adjustment. I do all of those on the wet bench. I have a base set up, but I have definitely learned that there's more ways to defeat idle vacuum than I can guess. Once again, I do know that frustration comes through in my voice. I apologize for that. I'm just trying to make videos to make where customers will look at this, or I can point them at something as they have problems in order to get through it. There's such simple solutions like putting a vacuum gauge on the engine while it's idling. But if people are unaware that that's done, or what the choices on adjustments are, then I can see where there'd be some confusion. But the carburetors continue to evolve to try to make them more sensitive to the less vacuum that's created by the idle transfer slot, to try to make it better. So I hope you have a great day, and I'll talk to you soon. Bye-bye.